All right, let's just jump right in. If you're an architect working with Google Cloud, you know the compute options can feel, well, a little overwhelming. So in this explainer, we're going to cut right through all that noise. Together, we're going to build a really solid mental model so you can pick the right service for the right workload every single time. It really all boils down to this one single question. Every decision you're about to make is basically a negotiation between these two extremes. Do you need absolute, granular, down-to-the-kernel control over your environment? Or do you need to ship features as fast as humanly possible, letting the platform do all the heavy lifting? This is the core tension we're going to unpack right now.
So, to make sense of all these options, we're not going to look at them like some random checklist. No, instead, we're going to arrange them along a spectrum. And this spectrum measures just one thing: how much of the infrastructure you have to manage versus how much Google manages for you. It's a journey, really, from those traditional virtual machines on one end all the way over to a completely serverless world on the other.
And here it is. This is the big idea, right here. On the far left, you've got maximum control with Compute Engine. Think classic virtual machines. And then way over on the far right, you have maximum simplicity with Cloud Run, where you pretty much just bring your code, and that's it. We'll see how other super powerful services like GKE fit perfectly right in the middle. This line, this spectrum, it's going to be our guide for everything else. So let's actually take a walk down this spectrum. Starting from the left, we'll check out each of these three core services, get a real feel for their specific trade-offs, and then pinpoint exactly what kind of workload is a perfect match for each one. First up, at that maximum control end, we've got Compute Engine, or GCE as you'll often hear it called. This is Google's Infrastructure as a Service, IaaS. And put simply, it's a virtual server in one of Google's data centers that you have complete and total control over right from the operating system up. It's really the foundational building block of the cloud.
And here's the deal. The trade-off is super clear. On the you get side, you see all the power. Full OS control, you can pick custom hardware, you can run basically any application you want. But all that power comes with the responsibilities you see on the you manage side. You own the OS patching. You have to build out the scaling logic. You handle all the nitty-gritty networking details. It's maximum power for sure, but it's also maximum responsibility.
So when is GCE just the obvious choice? This quote absolutely nails it. It's for that classic lift and shift scenario. In other words, you're moving an existing application to the cloud, but you can't or don't want to redesign it. If you have a monolith that just needs a new home in the cloud, as is, Compute Engine is your direct, no-fuss answer.
All right, let's slide over to the middle of our spectrum. Welcome to GKE, the Google Kubernetes Engine. Now here, Google manages the underlying virtual machines for you. Your new unit of work isn't a whole machine anymore. It's a container. And GK's whole job is to orchestrate all those containers, making sure they're running, they're scaling, and they can all talk to each other correctly. With GKE, the trade-off shifts. You get some incredible power, like workloads that are super portable, and this concept of declarative auto-scaling. You just tell Kubernetes, hey, I want 3 copies of my API running, and Kubernetes makes it happen. The price for that power? Well, you're now managing the complexity of Kubernetes itself. Things like cluster configuration, node pools, and its huge, rich ecosystem. And this right here perfectly illustrates the absolute sweet spot for GKE. If you're building a modern application that's made of lots of small, independent microservices, GKE is going to be your best friend. It is designed from the ground up to solve the exact challenges that come with that architecture, like scaling services independently and managing how they find each other. Okay, let's jump all the way to the far right of our spectrum. Maximum simplicity with Cloud Run. This is a truly serverless platform. You just give Cloud Run a container image, and that's it. Seriously. No servers, no clusters, no node pools to worry about. And here's the crucial part. If your service isn't getting any traffic, it scales all the way down to 0, which means you pay absolutely nothing. The trade-off here is less about infrastructure and more about architecture. You get this incredible pay-per-use model with basically 0 operational overhead. But in return, you have to design your application for it. Your app must be stateless, meaning it can't hold on to data from one request to the next. You have to be aware of cold starts, which is a slight delay when it's scaling up from 0, and there are limits on how long a single request can run. This is the poster child for Cloud Run, a stateless web service, like an API, that has really spiky or just plain unpredictable traffic. I mean, why pay for a server to sit idle 90% of the time? With Cloud Run, you only pay for the exact moment your code is actually handling a request. It's the ultimate in cost efficiency for this kind of workload. Okay, so we've walked the spectrum, we understand the options. Now for the most important part, how do you actually choose? Let's move from all this theory to a concrete, actionable framework. Here are the 4 questions to ask yourself. Step 1, just start with the app itself. Is it a legacy monolith or is it modern, container native code? Step 2, do you need deep OS control? If the answer there is yes, you're already pointing directly at Compute Engine. Step 3, are you managing a complex system with lots of interacting containers? Because that is the core job of GKE. And then finally, Step 4 asks about the scope. Are you deploying a full-blown application or is it something smaller, maybe more event-driven? This last question points to a very specific specialist tool. And that specialist tool is Cloud Functions. You can almost think of it as being even further to the right on our simplicity scale, maybe just past Cloud Run. It's not for running full applications, but for running small snippets of glue code that fire in response to an event, like a new file getting uploaded to a storage bucket. All right, let's put it all together. We have the spectrum, we have our guiding questions. Now let's apply this framework to 3 really common architectural scenarios you're going to face pretty much every day. This cheat sheet right here is the payoff. Let's apply our questions. Okay, scenario 1, legacy app migration. Does it need full OS control? Yes. Boom, the choice is Compute Engine. Scenario 2, a background worker. Do you need to orchestrate a containerized workload that has robust configurable scaling? Yep, that's a perfect fit for GKE. And for a typical web API, does it benefit from scaling to 0? Absolutely. Cloud Run is the clear, efficient winner. So let's just lock in the key takeaways. Always start with that fundamental trade-off, control versus simplicity. Use the spectrum, Compute Engine to GKE to Cloud Run as your mental map. GCE is for lift and shift, GKE is for orchestration, and Cloud Run is for serverless containers. It's really as simple as that.
So now you have the framework. The only question left is, when you look at your own projects, which workload are you going to reevaluate first?